Hello everyone, it's good to have you all here today. So this is the second video thinking about floating offshore wind in Taiwan. And we are looking at the opportunities for the supply chain and for industry in Taiwan to benefit from floating offshore wind. I'm Richard Burch, and I'm the offshore wind lead for APAC at the UK Department for International Trade. And perhaps I'll just pass over to you to introduce yourselves. Chris, would you like to say a couple of words?
Yeah, my name is Schraa. I'm the country manager for Mammoet. We're an engineering company by heart, specialist in heavy lift transportation.
Yeah. My name is James Lins. I work in the Fang Offshore, and we are the largest constructor in Taiwan. So we support a lot of the offshore wind developer to help them to complete the nearshore work. Yeah, right now. Thank you.
Thanks. Tom Whittle. I'm APAC director for OWC. We are a specialized consultancy focused on offshore wind. I've been working in Taiwan for the last 3 years, and personally I've been involved in floating wind projects since 6 years ago back in the UK.
I'm Ray-Yeng from Department of Hydraulic and Ocean Engineering, National Cheng University. I have studied the floating wind turbine about 3 years. Right now we have the laboratory tests and field experiment for floating wind turbine, including semi-submersible and the Burch type foundation. Okay.
Tom Manning, General Manager of CWind Taiwan. CWind deliver topside and subsea maintenance services and CTVs to Taiwan. Our sister company in Europe, Global Offshore, have been involved with some of the early demonstrator floating projects.
Thanks very much, everybody. So today we're thinking about the opportunity for floating offshore wind to contribute to Taiwan's industrial development. And Tom, I'd just like to sort of come to you first for sort of a bit of an overview. Could you comment on why sort of floating is likely to be such a significant opportunity for Taiwan?
I think firstly it's useful to point out some of the advantages of floating wind. So the main advantage is you don't have the constraint of requiring shallow seabeds compared to fixed bottom offshore wind, and that allows you to exploit much larger areas of seabed, which can be in places where there's less constraints or higher wind speeds, and you can have larger capacities of projects which drive down the costs with economies of scale. So they're the main benefits of floating wind. If you look at the market globally, the projections are that it's going to be a huge industry. I think the predictions that by 2035, the investment, the capex investment, will be representative of about $100 billion US, and by 2050, the capacity of floating wind is expected to be upwards of 180 gigawatts. So the global market is going to be huge. In Taiwan specifically, if you look at the water depth constraints in the Taiwan Strait and the available seabed area, it's likely that looking to the next 15 gigawatts of projects planned up until 2035, up to 10 gigawatts of that or more will be floating. So the market in Taiwan is existing and is going to be very large. So that's talking a bit about the market. And in terms of the opportunity for the supply chain, floating is in terms of technology relatively immature. So there is significant advantages for early movers in the industry, and Taiwan has that opportunity to step in and develop innovative technology to service that market.
Thank you. That's really interesting. I mean, the most superficial difference between floating and fixed bottom is the foundations. I'd be interested to explore that. What does that mean for Taiwan industry? Does that open up sort of any significant new opportunities as we move into floating? Ray-Yeng, would you like to come in there?
My briefing, I talk about we have the project from Minister of Science and Technology, and also from industrial investment like Honghua and Taiwan shipbuilding company. They want the floater can be manufactured in Taiwan. So for the project, we developed the suitable floating foundation in Taiwan Strait. So firstly, we have conducted experiment and the simulation for semi-submersible. This is for steel structures. And for the Burch type foundation, because we want to, the experience from the Cheng, the coastal engineering from offshore engineering for the Burch type foundation. So I think this is the chance for the Taiwan industry for floater. So this is a very good opportunity to develop the floaters in Taiwan. Okay.
Tom, do you want to add anything? I mean, I gather that the materials which the floaters were made out of isn't fully decided yet. Does that open up opportunities?
Yeah, I guess there's three main kind of manufacturing solutions for floaters. There's using traditional shipbuilding techniques to develop barge type or similar floaters. Then there's looking at concrete construction, where you can utilize existing onshore fabrication and manufacturing techniques to build the floaters. And then there's options to look at using tubular structures similar to wind turbine towers or monopiles. So there's the three kind of options you have to construct the floaters. And I think it's the optimum solution is not yet identified, and it might be different for different markets and different supply chains. And I think there's an opportunity for Taiwan to identify what works best for their existing supply chain and capabilities, and design solutions around that to really gain the benefit of this new immature technology.
Right. Chris, your company's been working sort of very closely on the fixed bottom foundations, and we know that Taiwan and Taiwanese industry have invested quite a lot around jackets and jacket fabricators. Are they likely to be able to sort of experience benefits from the move into floating as well?
I would say immediate. The conversion from jacket, pin piles and monopiles, all the technologies there, the investments have been made. We now see a supply chain in development. There's a lot of learning on the job, if you want. We're gaining a lot of experience in the industry. We're getting to certain levels of maturity in the supply chain. I think the industry in its entirety is very enthusiastic about the opportunities that floating will bring. We see new companies already gearing up and warming up to step into doing more. So yes, absolutely.
Thank you. Tom, just thinking a bit sort of beyond the foundations and sort of the broader industrial opportunities, do you think that floating offshore wind will open up opportunities elsewhere in the supply chain for Taiwanese companies?
Yeah, I mean, floating wind is comprised of many different components. So you can look at the mooring system, so synthetic mooring lines and tensioners and dampers associated with the mooring system and anchors, as well as looking at the dynamic cables and all the protection systems and buoyancy modules that are associated with the dynamic aspect of the cables. So there's a number of different components which the market is still nascent, and there's still going to be some early mover advantages for companies that step in there. There's also the engineering services for this new technology, which are open to Taiwan's making the most of the opportunity to export.
Right. And then so thinking beyond those, Ray-Yeng, I just wanted to sort of talk about, I mean, one of the things that I'm aware you're involved with is the sort of inspection and the predictive maintenance side of things. The underwater structures will obviously require a degree of inspection. Do you see opportunities there for Taiwanese companies to get involved on that side of things?
Yes, because for a floating system in the field site, we will have the healthy inspection. So to develop the underwater technology is also very important in the future, because for the maintenance, for the monitoring of the mooring system, cable and anchor system safety. So I think for this underwater technology like ROV, this will be features technology for the floating system investigation. Yeah, right.
Okay. Okay. And then, so beyond the actual components, and just to think about the installation process. I mean, obviously, it's a bit different. Chris, would you be able to talk about sort of the difference between a fixed and floating when it comes to installation and how that could play out?
From an engineering point of view, and for where we sit in the supply chain, we transport structures around foundations. We lift with large cranes. What we see in the demonstrator projects that we're involved with elsewhere in the world is that the weights and the dimensions are so much bigger than what we are used to with monopiles, pin piles, and jackets. So the challenge is really for companies how to get the structures into the water. And there's few methods for that. It's either lifting by ultra large cranes, of which are very few in the world. Mammoet is developing a alternative to semi-submersible by using a barge and strand-jack system in combination with our SPMTs, which we typically have on site to move large objects around. And that's really where, from an engineering point of view, it becomes really interesting to how to move these larger structures, space-consuming onshore, space-consuming in the port. So that's on the foundation part. And then what you see, the next step is the pre-assembly. The pre-assembly of the turbine, which typically happens in the port with the floater, whereas you in the current setup, you first install a bottom fixed structure, then there is either a transition piece where it goes straight onto a jacket. But these are separate parts in the supply chain, which now have to come together into, ideally, into the port where you are putting your floater in the water. So from space point of view, we have opportunities as well as challenges to cover.
Yeah.
And with that, with the size of the current demonstrator projects, in combination with the larger turbine size that which are now coming to the market, 14, 15 megawatt, the heights are increasingly higher. So more challenges to install in the port. So you get a high turbine on a high floater.
Yeah.
Very interesting.
Yeah, I can imagine. I mean, Tom mentioned that there might be sort of a degree of first mover advantage. Do you think in a Taiwan context, that's the installation is one area where there will be value if we were looking at this relatively early rather than coming to it sort of later?
Yes, but also no. Yes, definitely. But the time is now.
Yeah.
I would say the time is now for Taiwan getting into maturity, developing ports. We see a lot of activity in Taichung geared towards bottom fixed. There's still some other ports in Taiwan under development. I understand there is conversation about adding additional ports to the port of Taichung, like next to industrial zone number 2. I think it would be very interesting to see that floating gets a spot in these plans.
Yeah, I'm definitely going to come back to that because I think that's a really important point. And I just wanted to now come to sort of the maritime side. I mean, given the installation process is quite different for floating structures, what do you think sort of floating offshore wind means for the maritime sector, and where do you see the opportunity?
Yeah, I think absolutely. I think it's a good opportunity to Taiwan marine industries for floating energies. And because the maritime works for the floating winds is quite different. Their construction process is different from the fixed bottoms. So we need the vessel is also different. Maybe so we use the heavy cranes and the cable shapes is similar to the fixed bottom, but we still need another vessels like the large tugboat, multi-cat, and the anchor handling vessels and others offshore support vessels. All of these vessels have some very special properties, like the dynamics positioning. They have to make the very precision positions on the ships. And then we for the cable ships, maybe they need like the last system that they can launch the ROV into the sea and to doing the monitorings and the installation of the cables. Like I think the Tom we are at some opinion on that. But we need the vessels and in this moment. The Taiwanese company already bought some vessels can support the fixed bottoms constructions. But we still need to purchase. Maybe we have to charter another vessels from the other companies or other countries. And then we actually need some support from the Europeans. Even we already have accumulated some experience in fixed bottoms constructions. We still need to learn for these ones new floating energies in Taiwan. So we have to need the support from the Europe. Okay. Yeah, and like this one.
Yeah. Thank you. Tom, so we heard a little bit earlier about sort of some of the requirements that are a bit different around sort of dynamic cables and mooring lines, and I understand the installation is also quite different when you're talking about floating. Perhaps you could sort of comment on what would this mean and where the opportunities are on that side of things.
Sure. Maybe before I talk about the cable installation, I'll just follow up on what James was saying about fleet readiness here in Taiwan, because I think that's one of Taiwan's strong advantages, that a lot of the fleet development that's happened for fixed bottom has been in the vessel classes that potentially have greater utility in the floating sector, where a lot of the installation is more around towing of structures and anchor handling. And the jump for Taiwanese vessel owners to operating those vessels instead of moving up to turbine jackups and foundation installations is a much smaller gap to close. Obviously, the specialists that plan the operations, that needs to be developed, but I think it's definitely a reachable target for the Taiwan fleet. For cable installation, as I mentioned in the introduction, Global Offshore, our sister company, they've installed the cables for the Kincardine floating wind farm in Scotland, which is the world's biggest demonstrator at the moment. And a lot of that the focus within the installation for that project is around the front end engineering and design of the project. The cable itself has a different composition, different handling requirements, but the important work really for floating as opposed to fixed is in the upfront analysis of the tensions that you're placing a dynamic cable under, and especially how to manage the catenary of the cable within the water column. So making sure your planning covers modeling of the stresses that the cable is going to be subjected to as it transitions from a kind of fixed static cable in the seabed to a dynamic section up to the turbine. But importantly, also analysing how that catenary needs to be managed between seabed and foundation itself. So the right application of flotation sections, bend stiffeners. It's really important that's done a long way in advance in the development of the project, so that you're not left at the last minute with behaviours in the cable that you weren't expecting.
That's really helpful. And then I guess so. There's a follow-on question I mean, again, sort of CWind has sort of specialty around O&M. How do you see that changing as we move into floating and the opportunities there?
I think one of the big potential cost differences may be in floating when it comes to major component exchanges in the O&M phase, where you're potentially de-risking a lot of the operation with floating, with the ability to disconnect your structure and potentially tow it back into port, where perhaps main component O&M work can happen within the sheltered environment of a port rather than offshore, and again reducing the kind of asset class that you need to conduct that operation with. Especially when you're working in deep water, you don't have the ability to jack up. I think probably the other big distinction for O&M is something that Ray-Yeng was talking about with regards to the inspection of the subsea structure. There's obviously a lot less of it to inspect, and a big chunk of fixed bottom O&M costs comprises of kind of corrosion inspection and protection of the foundation structures, and purely because of having a lower volume of structure to inspect, you would expect that floating is going to offer some cost benefits in the O&M phase. As to whether technology to do that is going to evolve, I think Ray-Yeng's right to highlight the development of ROVs, particularly kind of autonomous underwater vehicles, as having a role to play in floating, as well as fixed bottom in the future. And I think that's potentially an area where Taiwan's high-tech industry can become more involved in the O&M market for offshore wind, not just floating, but fixed bottom also. I suppose the other thing that hasn't really been looked at yet in offshore wind that I'm aware of is what to do with the actual mooring lines themselves in terms of O&M. It's got lessons to be learned from offshore oil and gas, but it's a new component for the wind industry to tackle in terms of O&M requirements and how to develop the best practice for the inspection of those. And as a couple of other panelists have mentioned, whoever's got that first early mover advantage is going to be at the forefront of developing these processes and these technologies.
Yeah. Okay. Just to pick up on Ray-Yeng, I just want to go back to sort of the point, build on what Tom was saying around, we've sort of previously spoken, you mentioned that there were opportunities potentially for sort of research organizations and domestic industry to work together. Do you see that as one of the reasons why there's sort of a benefit from early deployment of floating, is because you can be at the forefront of this research?
Yes. I just talked about the Minister of Science Technology project. It's not only for government, but also for the industry, because they are interesting, because they think that floating wind will be the feature in Taiwan. So they investment for big money in our research for Honghua every year, about 3 million to 5 million NT dollars. Because this maybe in Europe this is not the big money, but in Taiwan, this university industrial cooperation project, this is the big money, especially for the industrial. They want to invest for the new technology for the offshore wind. So I think this is an opportunity, because the industrial, they see the future. So they want to cooperate with the university. And then besides the technology development, we also can training our students in the future. They can join the industry.
Yes. Yeah. Okay. Well, I mean, the opportunities for the supply chain certainly seem significant. I think you've all sort of covered that in quite some detail. But I'd be interested in just exploring a little bit about, your views on how Taiwan can maximize these benefits. Chris, just turn to you. Sort of, what do you see as the main questions, I guess, that are posed to the supply chain as we move towards floating, in terms of how it realizes the full potential of the opportunity?
I think for where we sit in the supply chain, it really runs around space, and so space to actually fabricate floaters, space to put them in the water, how to put them in the water, as we see from in different areas, different methods, and then how to install. So pre-assembly. So we've got an important but small part in the supply chain. From an engineering perspective, we always find solutions. So we never say no; it always can get done. But similar to what Tom mentioned, early engagement is key. Early engagement in the development of the supply chain would be really nice. So these conversations, like these panels, and with government bodies, with developers, gets the right message across. But that's really where we see opportunities as well as challenges. The space and time required for floaters to build and to launch and to install is way different than what we see with fixed bottom, which is more marshalling services, in, out, move them around. With floaters, you don't really do that so easily.
Yeah. And just in terms of, I mean, you spoke about sort of ports there a little bit and the need for more space. Do you envisage that there'll be need for significant investments in Taiwan around the port areas or changes to the port layout?
Well, where we sit, we always have a huge wish list of what we would like to see happen. It's more opportunity. I think a lot is already in place. There needs to be a bit of restructuring.
Yeah.
What's interesting in Taiwan, from a policy point of view, is that port space can only be rented out to a developer. So the developer holds the port area, starts and finishes his project in that certain area, and then hands it over to another developer. Where from our point of view, it would be really interesting if you can work with multi-user facilities. So you run 1 or 2 projects on one starts, uses an area, kind of stops, moves out, and another one comes in. At present, it is hardly possible within Taiwan. So it's more about optimization of the infrastructure that we have.
Yeah. Okay, that's very helpful. And then James, Chris just spoke about the port needs and needs for space. As a vessel operator, a vessel owner, what do you see as the current situation with ports, and do you envisage sort of any changes that you would like to see to make it?
Yeah, like the Chris mentioned, actually to be the constructor in Taiwan, we have a lot of the boats vessels in Taiwan. So we own about 16.5 vessels in Taiwan. So that's the actually happens in our our operations. Yeah, because when our vessel comes to the berth, it's right here, but we have to shift to another case because another boat into here. So there is a conflict between the offshore winds and the traditional port operations. So right here, so even so, there are 3 international commercial ports already involved into the offshore winds. They open to the keys to the offshore wind and elect to be the base construction base for the offshore winds. But actually, it's not enough. Yeah. And so we cannot burst the specified areas to fit our boats over there. So right here, so maybe so. In the future, so we want to make the port operations more smoothly. So maybe the government should be to make the master plans in the future to specify some special areas for the offshore winds and to service these kinds of workable vessel. Otherwise, we always conflict with the cargo vessels and container vessels. So we have to link the first to the other vessels. So it is quite difficult to the operator of the work vessels.
Okay. Yeah. Thank you. And then sort of just to follow on from that, I mean, we're all aware of sort of there's issues around shortage of crew and sort of onboard specialist technicians for some vessels. Do you see that as an issue that might carry over into floating? And should we be thinking about sort of the training side now for as a vessel operator?
Yes, because I think the floating offshore wind is a very good opportunity to Taiwan's marine industry, as I mentioned that. And but we have to make some preparations, in advance, otherwise we will lose the opportunity again. For example, we need some crews and some technicians on board. For example, we already works fixed buttons offshore wind about 4 or 5 years from the 2016 to up to now, so maybe 5 years. But we still need the crews. Yep, because the crew their training is for the commercial ports, not for the work vessels. Yeah, it's quite different. When they just doing the commercial boats, they just on there to operations, but for the works vessels is quite different. We not only to have to cooperate with the technicians, we have to make the position very precise. Yep. And we have to work the turbines. So we have to keep their straits up to only 0.2 to 0.5 degrees. Yeah. So it's a tough and the challenge, a big challenge to the vessels. So I think we have to train, and cooperate with the Cheng University. They can educate the students. And we make some programs, and maybe we can send some interns on the ships, because if we have the vessels, and we can send some interns on ships to practice and to learn the skill and to reduce the risk. Risk is the most important to the offshore construction. So right here, we can cooperate not only the university, and we can train these crews cooperate with the Polytech school. Yeah, that's it. It's more important.
Okay.
Yeah, thank you.
And
if I may add to that, sorry, we can definitely see the personnel shortage on the fleet. I think at the moment we're in a very interesting point in time where there's 4 projects under development at the moment. So all the available resources are being absorbed offshore. But also from our point of view, from an engineering company, heavy lift with specialist trailers, we also struggle massively to find local talent to come and work in the wind industry at large. And sometimes when I speak to my Taiwanese friends and acquaintances, we all know that Taiwan needs to go to a net zero by 2050. That part is now known, but the role of offshore wind to the general public in Taiwan is rather limited. People do not know about offshore wind. Yeah, we see some turbines, yes, but that there is all industry behind it that we try to make that, or that the government tries to make it like a localized industry. That is hardly known.
Yeah.
And from us, we face heavy competition from the semiconductor industry because that's such a endless pit for talent. Whereas we always say, well, our business is interesting too because it's there. It's a positive market. But to add on, there is opportunity for the policymakers to flag more about what the country is trying to establish.
Yeah.
Maybe if I could make one more comment around the skills topic before we move on, that I think, Chris, you're absolutely right that the industry already today struggles with attracting talent in and marketing itself as a career destination. I think one of the important things that industry and government needs to do with floating is demonstrate that it's it may sound like it's a new technology for Taiwan, but a lot of the core components are not new. They've been in oil and gas offshore for many years in terms of the mooring designs and submersible structures, dynamic cables. A lot of the engineering knowledge is pretty well established. It's being turned to a new purpose now, but I think it's important for the future workforce, but also the supply chain have built production lines and a business around supporting fixed bottom. That the transition to floating is making that link as important for the industry and government to do. I think it doesn't need to be seen as a big scary new industry. Now that fixed bottom's here, floating is a natural progression.
And just, I mean, are there aspects that we need that are in terms of skills that are different for floating that maybe we need to be thinking about now? Gaps in, perhaps I know that a lot of the skills in Europe have come from oil and gas, skills that exist there that maybe don't exist here, that perhaps we need to think about at this early stage?
Yeah, I think one really strong thing that Taiwan has going for it is the Taiwanese higher education system has a very high caliber of engineering education and development of future engineers. And a lot of the raw materials in a human resource capacity and knowledge can potentially be brought in to support the redirection of that caliber of engineers into, as Chris mentioned, maybe into more non-traditional markets. And floating wind needs to be one of those if the government's going to be able to achieve its targets.
Yeah, that makes sense. I mean, Ray-Yeng, you're coming from a university, is there any points that you'd like to make about the opportunities for training and skills development?
Okay, I'm from university, so recently I see that many students are interested in the offshore engineering because they see the job opportunity in the future. So this is the first thing I see. So many students want to be my student and and to conduct the research about floating wind project. This is the first thing. And the second thing is that when my student graduated from their master's degree, they can immediately get the job. It's also very, very important from university. And I also hope in the future, we can have the more opportunity to cooperate with the industry, because I want our research not far from the realized, not only for the paper publication, it must be applied to the industry after their graduation. That's my viewpoint.
That's really helpful. So, Tom, I'm just going to come back to you. Given all the various points that have been raised, would you have any overall recommendations or ideas to speed up the industrialization and the opportunity and maximize the opportunity in Taiwan?
Yeah, I think there's a couple of things that might help in terms of speeding up the industrialization and realization of the opportunity. I think really, a projection of a successful floating wind industry in Taiwan will give the market the impetus to develop the supply chain and take advantage of that opportunity. And so, how to give the kind of projection of the successful industry, maybe looking at some specific targets around floating wind, or looking at the supply chain plan. And the localization requirements, opening the quite prescriptive requirements around foundations to include floating. And then there's also the opportunity to maybe look at pilot or demonstration projects moving forward with government to support to give some confidence and reassurance to the industry that this is happening and it's happening moving more rapidly. And that it will be a successful industry, and that will bring the supply chain to have comfort and develop their solutions.
Yeah. Did anybody else want to pick up on overall suggestions for?
Yeah, I think one thing that strikes me about the floating offshore wind industry is that they seem very clear on what their asks are for helping for the government to help them to build supply chain. as Chris has mentioned today, is around making sure port infrastructure is suitable, that the fabrication process, the assembly process is understood by government, and they make allowances for that. And I think it probably, in a new market like Taiwan, what I hear a lot when people talk about floating wind here is that they need to see some sort of signals from the government that they appreciate the scale of investment and development required to hit those targets that they are planning to set for round 3 here in Taiwan. An example from earlier this week in Scotland, where a big part of floating wind globally is expected to be, is that they've made some big statement investments in port infrastructure, developing old disused ports specifically for floating wind. And that's the kind of example I think that industry and government need to be looking at planning for now to hit Taiwan's targets in the second half of this decade for floating wind.
Yeah. And I mean, another thing we see in Europe is some dedicated targets for floating, and also sort of specific funding mechanisms, such as the CFD process in the UK. Would those sorts of initiatives encourage more investment in the supply chain, do you think?
I think if you look at the UK and Scotland, they've now defined specific financial support for the pre-commercial size projects to help the industry move along from the current demonstrator phase before it gets to full scale commercial projects. And so that support will help the industry build the required supply chain and give it comfort that it can develop at the right pace and not just jump from zero straight into full commercial scale.
And then I wanted to move on to actually sort of looking at Europe. So we've seen the initial demonstration projects coming out of Europe, and these are starting to get larger, and we're seeing sort of the first pre-commercial projects in development now, and plans for the first commercial projects. And a lot of your companies have been involved in some of those early projects. I just wanted to get your thoughts whether there are any sort of lessons that we could perhaps take away from those first projects. That can we in Taiwan benefit from those lessons? I don't know who would like to go first. Tom, do you want to comment?
Yeah, maybe I can say something about the specific lessons that we've learned from the cable installation process. I think if you look at cable installation in general for offshore wind in Europe, it makes the news on a fairly regular basis for the wrong reasons. Being the principal cause of insurance claims, and we've seen some high publicity stories this year around the role maybe that the engineering and design of some of the cable protection systems are going to cause some problems in future years for existing projects and need to be designed out. And I think if you look at the transition from fixed bottom to floating specifically for cable installations, the issues around good cable installation practice and thought through fit for purpose cable protection system design become exponentially more important when you're talking about dynamic cables that have a far more complex arrangement of cable protection and flotation sections involved, and require a higher degree of accuracy in terms of cable placement and cable installation. And I think those we've seen in the fixed bottom industry in Europe that we're still not great at an industry at being consistently high quality in those two areas. So I think we need to make sure that as we move towards floating in Taiwan and elsewhere, we're learning lessons that don't have similar repercussions down the line for floating. Yeah,
that makes sense. Chris, did you want to sort of comment on?
I was just listening to Tom, and I can't give such an elaborate answer on this. What we see on the demonstrator, on demonstrator projects, there's the first one, and it's a bit of a general answer we always give. For demonstrator projects, people always have, there's a lot of time and a lot of money available, all eyes on the demonstrator. The challenge in the supply chain and now go and do it in series. and now you're under time pressure, and now you have to deliver, and now there is penalties for not delivering. And so it's very different. I mean, that's a challenge in itself, to move from a demonstration or pre-commercial to commercialization, because then we're not talking about 2 or 3, no, we're talking about 20, 30. So just to churn them out is hard. And what we see is that if you go into serious production, if you look at the pictures taken and all over the web on floating wind demonstration project, there's a lot of large, highly costly assets involved. And now for one of the projects in Scotland, the floaters are being made in Spain, they're being shipped to Norway, then there is pre-installation of the turbine in Norway, and then the whole thing gets towed to Scotland. You're not going to do that in series. Large cranes, large vessels, large organizations, multiple sites. So that is a lesson learned there, is how to condense that. Or sorry, it's not lessons learned, but the question is how to condense that and how to move away from this expensive assets, which you then need for considerable time. And that's where what I briefly mentioned, where we as Mammoet have come up with a solution using a barge on the floating side, so on the port side, with large beams and SPMTs on the land side, and then move the whole structure out, using partly the equipment which is already on site, a barge which is traditionally available in the country that you're at, and then come up with a new system to put a floater in the water. Alvin Singh from this morning's panel will not like it, but it will kind of take away the need for a semi-submersible vessel to do the same.
Yeah. Okay. Tom, did you want to come in with some thoughts?
I think the main thing is that there has been some demonstration projects, and there are in development small pre-commercial scale projects in Europe, and I think there have been and will be lessons learned. And I think the key thing is that Taiwan tries to build on those lessons and make sure it doesn't just make the same mistakes and have the same challenges that they experience in those trials in Europe.
Yeah.
And yeah, there's a number of ways of doing that, and yeah, I think that's the key thing for Taiwan.
Yeah. And I guess just sort of building on that, I mean, we're seeing, one of the aims for Taiwan for offshore wind is to become a sort of a regional hub. And we're seeing sort of projects in early stages in Japan and South Korea. Do you think that sort of we should be reflecting on those and sort of trying to develop an industry now that potentially can benefit from those developments and early stage projects there? Is that something we should be considering about, sort of the regional opportunity as well as the domestic opportunity?
Yeah, I think that's something that probably industry and Taiwan would benefit from now for fixed bottom, not just for floating. One of the big advantages for Europe is that ecosystem that's developed in the North Sea that allows a lot of cost efficiencies and economies of scale to come into projects. And I think still in Asia Pacific we're a long way from achieving that. And I think probably at the moment, regrettably, the kind of trajectory of the kind of three nations here, Taiwan, Korea, Japan, seems to be more towards a desire to do as much as possible themselves, which I think ultimately doesn't benefit the industry, although it may benefit the local suppliers. And I think arguably there are perhaps industry or companies in industry that are more ready to move into floating in both Japan and Korea than here in Taiwan. So I would say that Taiwan's got some ground to make up in some areas, but it has the opportunity still with the most developed fixed bottom industry in Asia Pacific, I think, to use some of that and effectively translate it to floating, to maybe make up some ground that it does. It's at the moment it's behind on.
Yeah. Okay.
If I may add to what Tom is saying, what we see in fixed bottom, as well as in installation of such, a lot of the knowledge transfer travels with the companies that are in these countries. Some of us here on the table have backgrounds in Europe, with companies that already have been in the industry for quite some time, and this knowledge is now coming towards Taiwan, and you'll see the same now with floating.
Yeah,
I think it's worth looking at the other markets in Asia, and there are companies making commitments to floating in Korea, and Japan is a lot of activity in looking at floating in the future. But I think Taiwan, with its kind of existing industry in fixed bottom and the targets they have, still has that opportunity to be the early mover in floating in Asia.
Yeah.
I think it's still up for grabs.
Yeah.
And with Tom, you mentioned there's some early mover advantage. I mean, do others sort of agree with that? Do you see a significant opportunity for industry in Taiwan if this was on an accelerated timetable rather than waiting for the technology to mature?
Yeah, maybe I'll say something about that to start with anyway. But I personally think there's quite a narrow window for some of the kind of more heavy industry side of the supply chain, fabrication here in Taiwan to catch that early mover advantage for floating, particularly with the regional competition it faces that I just mentioned. My personal feeling is that there's potentially more opportunity for Taiwan to target the O&M phase of floating as it would benefit from doing so in fixed bottom. And leveraging some of its high-tech capability to put it to good use in floating. I think one of the differences that will start to become more apparent with floating is the distance that you can place the wind farms from shore that Tom mentioned in his introduction means that there's potentially much higher logistics transit costs to get to those wind farms. You're operating in probably a more dynamic, more risky environment further from shore. So the amount of time you want people on these structures doing maintenance is going to be even more critical, and you're going to want to reduce that as much as possible. And I think with some of the early investment that Taiwan is doing now and research into kind of high technology, autonomous vehicles that Ray-Yeng mentioned, I think that might have greater applicability for floating wind farm O&M, where you want to reduce the amount of people on your platforms as much as possible.
I can see that.
So I think the vessel is also important that you mentioned that because we still need some different vessel for maritime works. And I think we have to make some earlier preparations in vessels. So maybe the government should be open programs to the university or some technical projects, and make the early demonstrations of the floating winds in Taiwan. So that will be more easier to let the marine industry to make preparations. Yep, that will be the more advantage to this industry. Yep.
Okay, that's wonderful. And then sort of one other point I would be interested to explore is the scope for sort of collaboration across industry. So I mean, do you see that as given that the technology is developing, the techniques, and it's all quite new, is it important for industry to think about sort of how it's working together to try and sort of in this development phase? Is that an issue? Both sort of within Taiwan, but also learning from, ensuring that Taiwanese business is able to learn from international companies that have been operating doing this in Europe.
Yeah, to be the local constructors, the Honghua and the Dongfang, we already sent some people to Europe, to learn the skills, how to operate for example, the DP systems, and how to handle the heavy cranes like this one. So I think this is the start points, and maybe so we are is an open mind, so we can cooperate with all of the international companies to cooperate with the local companies. I think it's okay for the local companies. Yeah, I think it's important because we still have under the learning curves. So we do not mature the skill right now. So we have to learn, and yeah, that would be better.
Yeah, I totally agree with James here. But it also comes to answer your question, or the answer to your question is, it also really depends on the DNA of the companies involved. The opportunities are there, and we know from European companies that they're very eager and keen to become part of Taiwan. Taiwan is now well known for many reasons, but in the offshore wind business, there's a real buzz around Taiwan. So there are, as you would know from the UK offers, there are many initiatives for collaboration between companies. And we also see that Taiwan has a serious competition from the developing market in the US. In what we do in the industry here, assets are scarce. The market in the US is heating up, and we see some companies, they need to make a choice. Are we going to the east or are we going to the west from a European perspective? I think that there's a massive opportunity for Taiwan to collaborate, but it really depends on, is the Taiwanese side ready to let the other one, let the other in? Are the circumstances right?
That's very helpful. And I mean, just as a sort of, I guess, last point, I mean, it's a slightly unfair question possibly, but one of the key, sort of aspects of floating is going to be cost reduction and reducing the cost, and we're at a relatively early stage. Do any of you are there any sort of aspects around things that we can do now that will set us up for being on that pathway and sort of successful cost reduction as it industrializes, or to support industrialization?
I think, mass manufacturing and production is one of the key attributes of floating wind, which will drive down the cost. They're huge capex heavy projects, and they require a lot of engineering and planning in the early stages. And it takes a long time to develop that. And especially for floating, there's an even more, essentially a longer technical development period to make that cost effective. So I think understanding that it does take slightly longer for floating wind to make that plan and getting the pieces in place to start that earlier is one of the things they can do.
Anybody else?
Maybe something that Chris alluded to earlier, when it comes to the actual construction of the wind farms offshore, that making sure your local supply chain is as well developed and integral to that as possible is really important. So you don't have like projects in Europe have had like large mass mobilizations in multiple locations, and that's something certainly that Taiwan can do and should do now, to start looking at which component parts of its existing supply chain, its existing maritime infrastructure need the development now to be ready to realise those cost reductions in 6, 7, 8 years' time.
Yep, so forward planning. Yeah.
Yeah, actually, it's the cost reduction is a big challenge to the maritime works. Yeah, because when we use vessels, when we berth in, so we need a lot of the money over there, and we have to keep the maintenance of the ships, and we have to get the crest for the safety. Yeah, so it's really the big challenge to the maritime in local time. Yeah.
Okay.
Yeah.
Okay. Well, I think we've just about come to the end now, of our time, but just left to thank you all very much for your time and contributions. It was a very interesting discussion. I certainly learned a lot. So thank you very much.
Yes.
Thank you.
Thank you.
Thank you.
Thank you.